Hello and welcome to my poster presentation for HAZ32. My name is Angus Keddie and I'm a HAZOP Chair and Process Safety Trainer for my own company, Process Safety Matters. The topic is how do we get to 2030 and beyond process safely. In this poster presentation, I will present some of the challenges I see for high hazard processing industries as they move towards 2030 and some potential solutions. I am a chemical engineer who graduated in 1986 from the University of Edinburgh. In the following 25 years, I worked in a variety of roles: process design, commissioning, training, sales. In 2011, I decided to try to become a HAZOP chair, and partly due to the backfilling requirement for HAZOP chairs caused by the measures taken by BP following the Deepwater Horizon disaster, I was successful. Since then, I have chaired over 100 PHAs, mainly HAZOPs, and developed several process safety training courses, presenting them internationally, both physically and remotely. In 2016, I started writing a process safety blog, currently number 80, some of which contemplated issues which were, in my view, likely to arise in the near future. I started to think that there may be some benefit to collating these ideas and subjecting them to informal peer review. I sent an abstract to HAZ32 and received the response that the technical committee would like more granularity before deciding. This prompted me to reach out to around 50 people in my network, whom I respected, to set up a working session to critique and flesh out some of the ideas. The subsequent exercises generated many insightful contributions, key among them from Dan Kokokaru, who's the ammoniaknowhow.com platform coordinator, Jennifer Skilling, Senior Chemical Engineering Lecturer at the University of Edinburgh, and Don Holstrom, Retired Director of the US Chemical Safety Board. A distillation of this interaction is presented in the forthcoming slides. The first theme is ever-increasing automation, both hardware and software. As operating teams get smaller and the time between interactions with particular plant interventions increase, there is an increased risk of hubris, feeling uncomfortable but not acting upon it, leading to incidents. The improvement of sophistication of simulators, e.g. BP Acetyls in Hull in England, have built a state-of-the-art, immersive 3D simulator which enables new and inexperienced operators to practice hazardous operations safely and help bridge this gap. Secondly, intelligent cameras to track releases and predict their trajectories, providing operators with intervention in real time. Thirdly, shared databases such as Fertilizer Fjorda Incidents Database, which addresses one of the 5 CCCP 2020 vision tenets, enhanced application of and sharing of lessons learned. And linked to that, fourthly, online tracking, accumulation and interpretation of operating data from identical or similar plants within a company, which can then be transformed into an agglomerated response. This would work well where a company runs multiple plants based on the same technology, e.g. refineries or fertilizer plants. We then come to the changing nature of threats: cybersecurity, man-machine interface, new processes and threats. Number one, operators in parts of the world which perceive themselves to be at elevated risk of terrorism are developing detection and reaction systems to prevent unit operations, plant or facility control systems being hijacked. Number two, the trajectory of high hazard processing industry operations has been for ever decreasing man-machine interface, at least when we talk about actual plant. The number of plant operators employed per ton of product produced has dropped rapidly in the recent years. This trend will probably continue through 2030. At the same time, plant equipment will evolve. This means that traditional team hierarchy will become less effective the further we move into the future. Fortunately, as we all share more than 99.9% of our genes, we can all learn to do pretty much anything anybody else can. Think of it as the human equivalent of stem cells from which we are all made. I am involved in the management of a 75-year-old intentional community near Oxford called Braziers Park. The residents all have particular skills, but due to relatively small numbers and multiple task requirements, all are encouraged to share those skills with fellow residents to generate redundancy. In the high hazard processing industries of the future, smaller operational teams will be encouraged to learn at least the basic aspects of their colleagues' expert function so that they can provide backup and alternation as required. Thirdly, the additive manufacturing industry is a 21st century phenomenon, and its associated hazards, which include dispersion of metal powders, potential carcinogens, exposure to argon, asphyxiation, electrostatic discharges, potential for metal dust explosion, and laser radiation need to be assessed and rendered a LARP. Novel technologies such as nanotechnology and their associated products are exciting and can drive future growth. However, the associated risks, negative externalities, may not be uncovered until the industry has become well established. This has been previously demonstrated in asbestos being a carcinogen, CO2 released being associated with global warming, cigarettes leading to lung cancer. An example could be bacteria killing non-smelling socks. Seems like a great idea, but what if negative externality in the future could be upsetting an ecosystem balance? The development of the nascent industry framework could incorporate tenets from the South African Truth and Reconciliation process, where punishment for apartheid-era crimes were commuted in exchange for openness about them, and that could be helpful. And finally, recent increased interest in manufacture of hydrogen is welcome but fraught with scale-up challenges. These, ironically, may be pronounced where this is attempted by incremental technology stretch than starting from scratch. The development of technology stretch management of change would address the subtle risks involved. An example could be that blending small amounts of hydrogen into natural gas used for domestic heating seems practicable, but you wouldn't want an upset to lead to high H2 concentration leaking domestically and accumulating in the roof of a customer's house. So now let's look at what won't change and why, including the ongoing need for curious, creative, communicative and empathic professionals. In his book Superminds, Thomas Malone, director of the MIT Center for Collective Intelligence, defines 3 key drivers of optimal group performance: social intelligence, equal contribution, and maximum female participation. Evidence is starting to emerge that remote HAZOps improving equalitative contribution by, for example, encouraging virtual hand raising and chat contributions. Should we push for a minimum threshold of women in future high hazard plant operating teams? Secondly, in high hazard plant process environment, any emerging incident has the potential to generate panic, which has a detrimental effect on decision making. Field operators could be furnished with crunched data suggestions for decision making as the crisis unfolds, perhaps with a short override window before automatic implementation. During commissioning an initial operation, the plant is likely to be extremely dynamic, simulating operator attention. However, after several months, this is likely to calm, increasing the risks of operator complacency as less and less happens. Consider using AI to overtly simulate deviations on the real plant to counter this. Regulators have always acted as the eyes, ears, and where required teeth of governments. The UK HSE, for example, was established as part of the 1974 Factories Act and tasked with inspection, assessment guiding, and as a last resort prosecution of industry to protect workers and third parties. Traditionally, communication has been in one direction. Governments make the laws while regulators communicate the relevant nuances to industry and ensure compliance. In an increasingly media fluid and flexible world, however, regulators may also absorb feedback from industry and communicate to governments to influence its decisions. An example of this was the work that the US Chemical Safety Board undertook in the wake of a 2012 process safety incident at a California refinery. The study recommended revisions to the state's PSM, Process Safety Management Regulations, emphasizing the benefit in terms of worker and neighborhood safety and welfare against a small cost, $0.004 per gallon. The associated legislation was passed in 2017. Remodeling PHAs for the near future, leveraging advances in AI without relying upon them. Firstly, compensating for the benefits of in-person HAZOP, reading room, proximity, etc., to be replicated by applying VR to eliminate downsides, travel cost, time, and associated environmental impact. Secondly, comprehensive root cause analysis with all steps from cause to consequence for relevant MAH examples available to counter the bold assertion that our plant is different from the one in which the incident took place. It would be countered by, that's true, but steps 2, 3, and 6 of the incident's root cause are different and therefore learning can be taken. Learning from industries already inhabiting our near future trajectory, aviation, semiconductors, etc., including military drones for plant inspection, nuclear, use of robots for maintenance, aviation, control rooms remote from site and used for plant clusters. For example, London City Airport is currently controlled from Portsmouth. Medicine maintenance on live remote plant, remote surgery, and UN peacekeeping vigilance engendering. The impact of Industry 5.0, the Internet of Things, personalized manufacturing, man-machine interaction, industrial upcycling. Sophisticated machinery to diagnose and fix themselves, personalized manufacturing, man-machine interface. Secondly, humans are inherently competitive, while HAZOPs are all about cooperation. AI has advanced so much since the inception of HAZOP 60 years ago, 2 to the power 25 according to Moore's law, so it should be now soon possible to develop a system which will take an existing or new design, apply HAZOP rules to it to identify gaps and address them optimally. What if we did that in parallel to an actual HAZOP and then compared the outcomes? Firstly, HAZOP team cooperation would be encouraged to generate an outcome which resembled that of the AI, essentially competing with it, and then have the power to override AI outcomes which jarred significantly with the consensus of the team. One example of this could be a HAZOP AI would likely dismiss any double jeopardy causes, but the team may reinstate some based on their experience. Novel techniques to support manufacturing, cloud computing, next level robotics, augmented reality. Nudges to generate safer outcomes. People have a strong tendency to go along with the status quo or the default option. Richard Thaler said in his book with Cass Sundberg, Nudge. Some high hazard processing companies are already working with robot dogs to assist in the critical phases of storage tank emptying and inerting. Any remaining operators will wear technology which will enhance their senses to recognize modern risks, enabling them to see into operating rotating equipment. And finally, The use of increased and more powerful AI to make routine decisions could free operators to concentrate on more exacting and interesting tasks. We have repeatedly risen to the process safety challenges of the past 2 centuries. We are now in an era of rapid and varied change, ever-increasing automation, both hardware and software, changing nature of threats, cybersecurity, man-machine interface, new processes, new threats, the impact of Industry 5.0, the Internet of Things, personalized manufacturing, man-machine interaction, industrial upcycling, novel techniques to manufacturing, cloud computing, next-level robotics, augmented reality. I invite you individually to choose and champion one aspect of this evolution. Mine may be competing human AI HAZOP teams to improve outcomes. What would yours be? Together, we can identify and address the process safety impact of this challenge. Thank you. If this brief overview has raised further questions, please contact me at the below email address.